Hi, everybody, and welcome to the Manufacturing Matters podcast, where we aim to get to the heart of the technologies and trends shaping the global manufacturing industry. My name is Jimmy Carroll. I'm the Vice President of Operations at Tech B2B Marketing, and I have the pleasure of being joined by our guest, Frederick Reinink, who is a Senior Business Development Specialist at Musashi AI North America, and of course, my good friend, Winn Hardin, Managing Director of Tech B2B. Today, we are going to provide an insight. Frederick, I should say, will provide an insightful look at some of the real-life applications and challenges in AI. So we're really looking forward to that. Before we jump right in, though, Frederick, I just want to thank you for taking the time today. Really appreciate it.
No, thank you for having me, Jimmy. Happy to speak about some of these issues around AI and how to deploy AI.
Well, we're looking forward to it. I'm sure this could go quite a long time, given the amount of questions I'd have about it. So we'll be mindful of your time, though, and limit it to 30, 40 minutes or so at the most. So anyway, Frederick, correct me if I'm wrong, right? But Musashi AI is a unique company in that you're part of Musashi, which is a Japanese global automotive supplier. So that in and of itself is unique. Tell me a little bit about the company's background and how Musashi AI fits in.
Yeah, no, great question. Well, we see that uniqueness also as an advantage. So to your point, Musashi Sumitsu has a long history of being a tier one automotive manufacturing organization. Obviously, throughout that history, well aware of manufacturing processes and quality processes. And that's really where my group kind of got its foundation, was through observation that within manufacturing facilities, about 20% of resources and costs still, we're going towards final part inspection or quality related processes. So the organization, looking at some of the new advancements that were happening with around AI and capabilities, put resources across a few teams in the globe. My team is working out of Waterloo, Ontario, Canada. And then from there, with the results that were shown, it officially spun off as a separate business, a technology-focused business. And that's where my group, leveraging a lot of the experience that Musashi has as an automotive manufacturer, but also recognizing that the same issues and problems that Musashi was facing, other OEMs and tier ones and tier twos were also having those same challenges, kind of recognizing the market for the technology. That's really what led to the commercialization of the business unit. So
that's great. Again, thanks for joining us, Frederick. So I think it gives folks a lot of confidence when they know that you're eating your own cooking. I mean, you're putting your own systems and softwares through the trials in really high-paced operational environments. So I look forward to talking more about the tips and tricks and the advice that you can give folks, for sure, when we're talking about getting ready for these applications, setting them up, and what to do during operational components. But we're coming right off of Automate. We're recording this show not too long after the Automate show up in Chicago this year. So you want to give us a quick rundown on what was new and cool for you at the show?
Yeah, sure. No, so Automate, this was our third year attending and exhibiting. Musashi had a larger booth presence this year compared to past shows, but also new location for us. The two previous shows were in Detroit, this year in Chicago. Our main booth, so we had we designated kind of three areas where we were demoing different product. Our largest footprint was around what we call our automated inspection system. So that's a cell that can accommodate automated inspection, and then in the part that we were showing was an automotive engine part. We received a lot of compliments on what that system demonstrated. So it did a really good job explaining kind of that hardware side that Musashi also supports during vision applications, right. But also all of the software that we would deploy in a production setting was running on that system as well. So kind of was able to also handle the conversation on what does software look like, and what's the capability on that software. So that cell was really beneficial to have there, and I thank the team that put a lot of hours into getting that ready for us. Some of the other stations were more on some of the software products. So post inspection, we like to have data be available through an application that's browser based, so it runs in the AWS cloud. Quality staff, operations, floor staff have the ability to see what's actually happening on, through that system, all of the output, any of the trends. Yeah, so we had a second station where we were demoing capabilities of that software platform, just kind of a large screen. Again, a lot of good feedback because quality traceability, especially in automotive, is such a huge kind of forward-looking requirement. And with that platform, we can kind of give indication of how we can deliver traceability from a quality perspective, and that got a lot of positive feedback and questions around. And then following that, the third kind of station was around a mobile-based product that we've created to assist more with quality sorts. So, unfortunately, sometimes things get sent to an end customer, or you catch something and you quickly got to assess status of parts. So it's a mobile-based application that you can use on your device where you can scan the part ID or the laser engraving, and it will give you images and the record of that part. So it's a way that can accelerate, like I mentioned, quality sort or containment use cases.
And helping to protect those customers who may not want to have to return or receive an entire shipment sent back to them because someone's saying that the defect happened at your end when, well, no, we've got good image proof and archives that that's not the case. It shipped out fine. It met all specifications. So that's important. If I could ask a follow-up question, do those demos of Musashi's approach, do they include both traditional machine vision capabilities for inspection as well as AI, or is this a pure AI?
No, of course. I mean, we use leverage traditional machine vision where it's appropriate. I mean, things like presence checks sometimes, or some gauging checks that we're doing.
Gotcha.
You're gonna still utilize some of the traditional machine vision algorithms and code, but a lot of what we do is AI based, or specifically deep learning based. So.
One more before I let Jimmy jump in again, because I'm sorry, I always have too many questions, Frederick. You got to bear with me. But so we talked about ease of use for sure being a hallmark of the Musashi application or software platform environment. SPC reporting back. Are there any other primary value differentiations that you were talking about at Automate, either number of checks, autonomous or unguided self-learning to be able to kind of follow changes in a process? SPC and ease of use are obviously the top two and I'm loving hearing people talking more about SPC, because so often that data in a traditional machine vision environment has been maybe captured but never really used. So I think it's fantastic when people talk about how does AI need to get into manufacturing? It's that attention to detail, and that ability to get that siloed data into an environment where you can extract intelligence that we haven't seen, and I'm glad that we're seeing it now. But again, any other key value propositions from the Musashi platform?
I mean, I would say from an inspection standpoint, really our value proposition is around automating full part inspection of complex parts. So this is where, there's a lot of vision out there. And it can be the right application. Less complex parts can be solved with kind of like off-the-shelf systems and those types of products. Where our value proposition is, for example, like a really complex automotive transmission part, where there's going to be some customization either from the code itself to kind of manage how the inspection happens, but also the AI models themselves. You're probably going to need a lot of application-specific data, let's just say that.
Right.
And that's where our engineering group, we apply a turnkey approach to delivering that. So really from the end user or the customer, we see them as subject matter experts. So they know their parts, they know their processes, but from a quality standpoint, they give us direction as to this is what the quality check is going to be on this part. They give us the part drawings, part samples themselves, inspection documentation and workflows and requirements. And then it's our engineering group that works with them, collaborates with them, and then we create the software to do that. So that's a differentiator. We deploy or hand over turnkey software.
I suspect we'll talk more about that too. Thanks for bearing with me on that, Frederick.
No, good. And I agree with what you said. I mean, data is such a wonderful byproduct of AI. So not only do you get kind of consistent, accurate, reliable inspection with AI, but AI, can process what's happening in an image in an instant, and it can, kind of automate some of that difficult or time-consuming data capture. And that's really where, to your point, once you have that data, now you can add additional value and insights on top of that, and that's really where organizations can really leverage AI.
Cool.
Frederick, I think some of these responses, I don't think that some of these responses are really refreshing to hear, because if you go back, and if anyone who's listened to multiple podcasts has heard me say this, but it's hard not to repeat it because it's just true, right? If you go back 7 or 8 years ago, deep learning was sort of being not reintroduced, but deep learning kind of emerged in the industrial space, and a lot of people were hyping it as this technology that was going to take things over. And then, yeah, exactly. It was shiny, it was flashy, it was exciting.
Those are my Monty Python hands, by the way. Oh, there was a little hum in the background.
Yeah. So, in recent years, though, and again, like AI and deep learning, these aren't new technologies, but in the industrial space, it seems like in recent years that the technology has sort of settled into a well-established group of applications where it adds real value. I think Musashi AI is a really good example of that. Like, you're targeting the inspection of complex metal parts, and not just, and pairing it, like you admitted that, not admitted, but you are pairing it with traditional discrete rules-based machine vision algorithms and technologies. And now we're starting to see AI as more of a larger tool for the toolbox than a magic bullet that's going to come in and change everything. And it's just really interesting. And over the last year or two, I think it's really come about. And there's not really much of a question behind that. I just wanted to tell you that, and I guess follow up and say, like, you've touched on it a little bit, but do you have any other sort of fundamental, what's your fundamental approach to AI? Do you have anything that you guys were internally, what's your general approach, I guess?
Yeah, no, I mean, our general approach, as kind of we talked in the intro, customers need things that perform, right? They need an AI system or software that doesn't require a lot of intervention. So at the end of the day, performance is going to be really, really important to them. Maybe one of the unforeseen hurdles or challenges is around data to get an AI that can meet performance expectations. So really, like, our group, a lot of the investment in R&D, a lot of our intellectual property, our patents are around that software piece, and we're really looking to bring down amount of data required, but improve the performance of the system. So,
and we're really specifically talking about customizing some pre-trained models, right? Basically optimizing it for the customer application itself.
Yeah, and we've got what we call our active intelligence algorithm at Musashi, which is a fusion of 2 types of algorithms: anomaly detection and segmentation-based models. And there's advantages to both algorithms. Right. And we've done some enhancements. We've created this architecture, which we call our active intelligence, which is not self-learning, so it's still human in the loop with engineers, just due to concern about things like model drift or kind of performance. But we've seen that have really good impact on ability to create a production-ready model in an accelerated time. So the time to value of the solution is really what we want to achieve with the customer and deliver to the customer.
Would you say that developing those initial optimized data sets to be able to train the AI models, that still remain the largest challenge for customers when they're trying to implement AI?
It's certainly one of the largest challenges. I think when we engage with the customer, it's really important that they assign someone that's going to be kind of like their subject matter expert and kind of remain consistent, so that they can define what the system requirements are, what the quality inspection requirements are. Because without that, you're going to spend a lot of time going in different directions, trying to accommodate different people's opinion. You really do need we call it ground truth. You need them to agree on what ground truth data and requirements are. And then that's where our group can begin to work towards delivering that. Right. Once you have that established, then I would agree, yes, having the data becomes the largest hurdle to clear to get a production-ready model.
Absolutely.
Yeah.
Frederick, given your role as an automotive parts supplier, or your parent company's role as an automotive parts supplier, right? I do want to ask about different applications and where deep learning and AI have become really popular, right? I guess EV battery manufacturing would be one of those. So how has the development of AI and deep learning technologies over the past few years impacted manufacturing, battery manufacturing?
Yeah, sure. So, I mean, we're looking at these applications, and the feedback that we've had through through meetings is that, the same benefits that deep learning have delivered to other industries, including traditional automotive or medical or heavy industry. It's around that performance piece, and performance can mean better detections of true defects, but it's another maybe point that's not really thought about is the false positive rate. Right, this is where you get a lot of issues with systems historically, where the number of rejects or kickouts produced by the system make it's just not something that can actually ever get deployed without consistent or constant interventions by production groups.
Yeah.
So going back to EV, there's going to be new use cases, right? New types of products being made, new processes being used, laser welding, and we've had some interaction with laser welding companies, and there are quality issues that are presented visually. So this is where a deep learning based 2D or 3D system is going to add a lot of value. And it's my understanding, or it's been communicated to me, that the challenges of a lot of the existing technology providers is around that false positive rate. So it's just something that creates issues. And if AI can bring the false positive rate down, in theory, it's going to be a better technology to manage inspection.
And really, I mean, that's one of those. It's a challenge that's been with us for a really long time, right? Being able to set that perfect threshold. How much waste am I willing to put up with versus what's the downside or liability with shipping bad quality parts, right? And every application's got a different sweet spot in that area. But I love what I'm hearing from you, that combining traditional inspection approaches with AI helps to reduce those false positives, which means overall you're going to get better quality goods going into the marketplace. And especially in the case of EVs, where it's really a safety critical system, this is super important, right? And the only other option is to just throw, a ton of manual laborers, hope you catch them on a good day, or manual inspectors, and that kind of method, and hope and pray, as we've done for literally hundreds of years for those types of applications.
If those manual inspectors are available, given the persisting labor shortage, right?
Very true. And didn't have a late night the night before, and it's not the 6 hour, they're 8 hour shift. And, I mean, very difficult to keep that level of awareness, for a whole shift, which is traditional. Frederick, have you done any kind of looks in terms of, or can you give us either a generic case study? How much have you been able to cut false positives for some of your customers? What can people expect to get if they go through this process?
Yeah, no, I mean, sure. I can talk about projects. I can even say, like, I know when you speak to someone that's interested in deploying an AI system, of course, they're going to say 100% detections, 0 false positives. That's always kind of like, yeah, perfect. That's the perfect system. But
it goes back to the Holy Grail. That's where I bring Monty Python back, But anyway, sorry.
But if you quickly talk to them, you'll be able to explain to them why that's just not achievable, right? I mean, unless it's a really simplistic application, it's not achievable.
Right.
But it's been our experience that, and we've done like proof of concept projects with organizations where they're very new to AI, very complex part. They didn't know necessarily, how well this software was going to perform with their specific part or for this application. Right. Typically what we see, let's call it an 8-week project, proof of concept project. Initially, that first week, there's going to be a lot of image acquisition, and we're building data sets at that point.
Yep.
And we're making optimizations. By the second week, you're going to have a much better performing model than you did, as you started the project week 1. And then typically by the third week and the fourth week, assuming that you've had like steady throughput and you've got kind of new data, by week 4, you've got something that pretty much go into production setting. So this has opened a lot of eyes. It also, we try to educate the customer prior to the project, like this is going to be the life cycle of the project. You can't expect something, week 1, just due to how AI is dependent on data, right? And that's really it. The more data, the sooner that we can acquire more data, And it's not just any kind of data, right? It has to be representative of, defect data or, good part data. But a lot of times it's more the defect data that's of interest because you're training like segmentation based models on no good data or defect data. So,
Right.
we communicate that and they understand it, but when they actually go through it and they can see, oh, a part that was run week 1 was missed, but week 3, now there's an algorithm, and every time we run it now, it's caught, and they understand it, they get it.
Well,
and it
absolutely. And a complex engine part may have dozens of inspection points, So I mean, if you think the fact you're even talking about fielding a system within 4 weeks, when a rules-based programming approach, even assuming it was fixtured, even, which is a big assumption, right, would at least take that, if not more, for bugging and troubleshooting. So that's super impressive, and I think we'll probably touch back to this as we talk more tips and tricks for the customers out there when we're considering these types of systems. But the fact that you have a real world approach to this, it's still HIL, human in the loop, during the initial training phase, and that you're providing that engineering support. I mean, your systems are easy to use, web-based browsers for sure. You don't need data scientists to be able to evaluate, but these people may not be inspection experts. They're experts in building powertrain parts.
Yep.
So the fact that you're willing to support them from the beginning to the end of deployment, I think is a very realistic and the only way that you're going to achieve that kind of high success rate in a 4-week time frame, which seems to me to be very compressed. I mean, that's being able to produce a system for complex inspections within a month is killer. That's a big deal.
Yeah, don't get me wrong. There was a bunch of work done to produce like the hardware element of that solution. So that 4-week is really when that system was at the customer site and we're taking in their data. So don't try to make it sound like we can deliver a project in 4 weeks.
Okay,
but like this, the software lifecycle, certainly once you have data, it's really impressive because like I said, I've seen that wow with the end user or the end customer where they said, okay, this has gone from, wow, we weren't quite sure how it was going to perform to it's exceeded our expectations in right. days or weeks. So that's really the benefit of AI. And to your point, the amount of time and resources to create these algorithms, and it's not a single, what we call a region of interest or ROI. We're looking at, 10, 15 ROIs for 20 to 30 defect classes, not a single defect class, right? So right. You need something that's very robust, and that's maybe the benefit of AI. You can create these really, really robust, adaptable solutions with the customer.
And that hardware development would be done, whether it was through a traditional method, or an AI combination hybrid method. So you were never going to get away from image acquisition, lighting, and trying to figure all that out.
You nailed it, Winn. Yeah, exactly. The only change is that AI is the software that's actually kind of processing images or inferencing, as we say. You're exactly right. Everything else would be standard, whether this was an AI-based or non-AI-based solution.
Right. And in many of those cases, the traditional rules-based model would have never been able to complete these kinds of inspections anyway. Not anywhere near that kind of level of confidence.
Well, 100% right, Winn. And that goes back to why my group was created. So some of the applications that we're currently developing for were previously attempted to have automated using rule-based, non-AI-based systems, and there was all of those projects failed, unfortunately. I mean, it would have been great if they could have solved it, but it wasn't feasible, and for the reasons that we talked about.
Yeah, and now here we are 5 or 6 years later, and I'm sorry, Jimmy, but here 5 years ago, 6 years ago, a lot of integrators were very concerned about trying to adopt these AI solutions. They didn't really understand them. The level of integration, processing capability, and the software itself wasn't as user friendly. They might have spent an awful lot of time on NRE trying to solve an application that could have never been solved previously. And here we are solving those applications within a month, 2 months with total optimization, programming, debugging done. So we've come a long way in a relatively short period of time. It seems like for an old guy anyway. So
well, that's actually a perfect segue to one of the questions I wanted to ask Frederick, which is about, it's almost like, maybe some of the initial challenges where AI is not a good fit for the job and people didn't really quite understand it yet. It's almost as if it's like industrial AI 2.0, right? What are some of the challenges you're seeing now? Like now that deep learning and AI have been sort of established tools, they are established tools, obviously. What are some of these new challenges that you're seeing? And do these challenges change if you shift from small, medium, large enterprise?
Okay, yeah, good question. So me kind of being in the business development role, customer facing, a lot of interactions with customers, I would say like educating on the the delivery of AI, right? Keeping expectations where they need to be realistically. I think things like ChatGPT just kind of put people's expectations for what AI can do out of the box at a level that's not achievable. They've got a fantastic product there, and it's a specific type of AI for a specific use case.
Exactly.
So for me, it's about managing and making sure that the end user or the customer understands how the process is going to unfold with their application. And that means, data, of course, we have that conversation around data, getting a sense of like how soon we could put together something that will be deployable. But even long term, so this goes into any kind of production deployment. What happens if there's a change, right? Something changes. You might have a different supplier for a particular part, and that could have like a minor impact on the surface appearance.
Yeah.
That's really where our data product. So over time, any changes, end users have the ability to create what we call like notifications, or they give us insight into, okay, the AI said this. Can you look at this? Can you evaluate with us if we need to make changes to the system? So that keeps that ability to track how the AI is doing long term across the deployment. So yeah, I think the biggest thing around now is making sure that people don't expect too much,
Sure.
but at the same time, wanting to provide them, good indication of where it can get to. So like not overpromising, being very realistic in where an AI-based solution can get them.
Yeah.
Yeah, we're notifying them when yields are starting to drop down because of variations from various suppliers, whatever the issues, and then giving them the tools to be able to say, do we want to modify our basic model, or is this a temporary blip and ergo no, or I like this because it's more specific. So many times when we talk with folks, it's, our AM platform is really super easy to use. Okay, well, that sounds great. But how, and you're talking about consensus building, or ground truth, as I think you called it earlier in the day, which is a very common thing that most folks don't talk about when they've got inspectors, not just multiple inspectors in a single facility, but now you've got 20 facilities around the world, gets incrementally, exponentially more problematic, and things like other things you said, like having multiple 10, 20 class defect classifications within 12 or 15 different ROIs. Each one can have that same list subset. So it's very
that
cool.
Data will produce bad results, right?
It's every time. Yeah.
No, you're right, Winn. Like yield is, of course. I mean, like our solutions can't create new problems for the manufacturing group, right? So that's where we feel we have to understand with them, if there is a change, how can we react in the way that they want us to, that they want the system to, right? Some of these new things, let's call it an anomaly. Something comes up. This could be something that they look at, they evaluate, their quality group says, yep, we've looked into it and it meets specification. So can we have your model, either detect it or pass it, or just have your model not even detected anymore? That's really the conversation that we have post kind of deployment of a production algorithm.
Absolutely.
Yeah.
Cool. So you've talked about some of the challenges: data acquisition, optimization, growth over time. If someone's considering an AI model, an early one, we talked also about setting expectations properly. This is not a large language model. This is a much more complex element that we're talking about here versus the ChatGPT. But do you have like 3 or 4 suggestions that when people are considering this application, you tell them, okay, before you come talk to us, these are the things you really want to think about?
Great question. I'm gonna think on it a little bit, Winn.
Sure. We'll give you like 3 whole seconds, Frederick. I mean, it's always defining the specification, right? That's always a common challenge.
Well, that's what I was going to say. But the specification, really, there should be a good business case behind it, right? Because if it's really your organization's first interaction with an AI system, you're going to want it. You're going to want it to, like you mentioned, build consensus for this technology at that site, right? So you want it to have impact. choose maybe an application where it's the first, like the AI group says, yes, this is a good problem for us to solve. It's not outside of kind of scope of what we could deliver.
Yep.
But then also like the customer site is going to say, yeah, this is going to have a major impact either through, improved quality detections, less claims or warranty issues or whatever that could be. Maybe it's a cost element. Maybe, automating this inspection is going to allow that organization to put human capital into other areas, and that could have a lot of benefit. So I that would be one of the conversations I would have with anyone considering AI, is just make sure you're choosing a use case that's going to, meet what you want out of the system from an AI perspective, but is going to deliver maximum value.
Right. From a TCO, from a total cost of ownership, including soft returns, about the ability to move inspectors to production line monitoring and other places where you've got labor gaps and you've got challenges going for a while.
Yeah.
I think that's
like I know I've talked to organizations where they've got a particular defect that they're having issues with, and they're evaluating different technologies. And when it comes to AI, a lot of the time they're unsure how an AI model would do with that particular application or that defect.
Yeah.
And then this is where like proof of concept. So maybe that's another suggestion is, if you've got something in mind, what is priority for your organization to have kind of validated or confirmed by an AI system? And if you can identify something, you could do this in a very low cost way. AI gets trained, you've got some software, you can run it either, in the technology organization site, or you could potentially do something at the customer site or user site.
Mm-hmm.
And to me, that is, the buy-in is so strong when they can see that software operating in their facility with their parts.
Right.
So like proof of concepts or proof of principle projects can be a really, really great way, low cost way to build, to get that buy-in, de-risk some of the concerns that they might have about adopting an AI solution.
Mm-hmm.
And if you choose wisely, you don't really have to say, well, we have to do everything that a production solution would do. It'd be like, no, if you can prove it out on, these two defects and on, these two regions or surface areas, we've got enough trust in the system to go forward with a production deployment.
And luckily the customers have a partner in Musashi who's willing to help them through at least, some little part of that POC.
Yep.
So that, because, and most of the customers, they don't really think about, everyone brings pie in the sky ideas to so many of our machine vision automation integrators, and, looking for that silver bullet kind of scenario. But it can be hard on your end, right? How do we manage which projects we're really going to investigate and try to help solve where we believe we have a good confidence level of success? So,
right.
Do that TCO, do that due diligence beforehand, and come up with a subset and a reasonable POC, and then that can make a real difference.
Yep.
Cool.
Yeah, Frederick, I like to close with asking if you have any trends or predictions for the industrial automation space, right? But before I do, you brought up ChatGPT, and I just have to ask, not specifically about ChatGPT or large language models, generative AI, but if you're having a conversation, whether it's, a person you meet on the street or a family friend, or if you have kids, a kid's parent or something, and you tell them what you do for work and you explain to them that your company works in AI, how do you talk them down off the ledge? So many people fear AI. And it's like 7 or so years ago, there was this conversation about robots are going to take our jobs. Well, that's been proven wrong. And now there's this like new conversation of like AI is going to take over the world. Well, no. How do you explain?
Might be better if it did, but yeah.
At least in the US.
Yeah, no, great question. So when people ask and I try to give them an overview of what I do or what my company does, I immediately start to talk about quality, right? Quality applications. So we're an image-based AI processing company. Our algorithms really are for processing of images. Everyone's got an opinion about AI, myself included. I think obviously it's going to deliver a lot of value to manufacturing, just to kind of the general public. Certainly, like it has to be done in a way and delivered in a way that doesn't compromise anything around safety, or we're still under obligation through our projects to meet all of the the requirements that they have regarding kind of a safe workplace, making sure that our system's reliable. Like they do reliability tests with our AI systems in the same way that they would do with a non-AI based system, right? So it's not like, oh, AI, if it's AI based, it's a shortcut to having something put into a production deployment. Not the case at all. We still have to kind of meet those requirements. But overall, like I am very positive on what AI is going to do, especially with impact to manufacturing. I think there's a number of ways, quality applications, of course, but even outside of quality, there's so much to do around just kind of general optimizations. I think most of us are using something like large language models on a daily basis anyways, just in our regular jobs. And, we see the benefit, we see the impact of it. And hopefully it is allowing us to do things quicker, or spend less time on those activities where we could use that AI.
Yeah,
without question.
Sure.
Yeah, even if you're not a huge Chat GPT fan, the fact if you're asking Alexa for information or Siri or anybody, you're using a large language model whether you realize it or not.
For years,
yeah. I mean, like Microsoft has AI baked into it now, right? Like
Yes.
even Excel, and I like it. I mean, it works. It delivers things in a way that it almost is intuitive, right? Like that's when people I think have that experience with AI where it's more on, oh, this is better, this is done faster, or this is more consistent. That's where people say, okay, I get it. This is a good application for AI. And then to the point about people worried about it taking away their jobs, that's where there's concern. And I don't think AI is ever going to replace someone's job. It's really you learn to use AI in your job.
Over and over, we've seen automation increases headcount across because companies are more profitable and they're able to hire more people. So there are no outliers where that's not the case. So
for sure.
Yeah. So Frederick, kind of the closing question I like to ask, and I'd like to frame it, I guess, in the context of Huang's law, Jensen Huang from NVIDIA, who said years ago that the rate that GPUs are advancing is significantly faster than traditional CPUs. And I think it's not necessarily a coincidence that we've seen a lot of AI deployments increase as these other technologies increase. So just with that in mind, are there any exciting developments you see in the next 2 or 3 years based on the advancing capabilities of not only industrial computing, but deep learning models and cameras and beyond?
Yeah, great question. So my group, we work with NVIDIA a lot. We attended a session where Jensen was speaking last February, and even now, as far as the industrial compute market has progressed, they're still anticipating just further enhancements that are going to allow AI-based companies to deploy latest and greatest new types of models, right? New types of architectures that, again, really are going to have more positive impact on outcomes of projects, either from a cost perspective or performance perspective. So we're excited by that. And that's really where, our software group, they spend time and effort making sure that they're keeping up to date with what's available, what shows promise and what we could utilize within our technology stack. Regarding cameras, I mean, even things like 3D-based image acquisition has certainly come a long way in the last 5, if not longer, 10 years. But again, quite excited to see where that's going from a cost perspective, from a capability perspective. And I do feel like that's really going to lead to a lot more value in vision applications. So. And then some other technologies as well, probably too many to name, but certainly quite excited. Certainly, I think there's just going to be more ability to integrate AI across more applications is where I see that going.
Mm-hmm. Yeah, cheaper, easier, for sure.
Yeah, I can't wait to see what AI does with, when it's regularly using 3-dimensional data. And not just in the industrial space. That's because we always break the trails for the most part. Although, I mean, academics are out there doing amazing things and they're bringing new ideas and we're leveraging that. So I don't mean to steal their thunder. Without them, none of this would exist. But our deployments in industrial seem to be more refined. I mean, we don't do everything, but what we do, we develop really, really well. And I kind of would see more the flow going from an industrial application leveraging 3D for AI than, say, autonomous vehicles, which are using low resolution, multi-layered sensor networks. I guess it'll be interesting to see, but that'll be fun.
I agreed. I think nobody knows what that new great technology could be a year or 2 years from now.
Yep.
But yeah, I kind of excited where the general direction of AI is going, and then some of these other modalities as well. So quite exciting.
Absolutely.
Yeah, absolutely. Like in the same way that we'll follow along with developments in computing and cameras and so on. It'll be interesting to follow the progression of Musashi AI. I've had the pleasure of meeting up with your team in the last 2 automates, and next year I look forward to seeing what you've got. So, Frederick, again, really appreciate the time. If anybody would like to learn more about Musashi AI, it's musashiai.com, or you can reach out on LinkedIn. Or reach out to us at manufacturing-matters.com. We'd be happy to pass along any questions to Frederick and his team. And once more, Frederick, really appreciate it. Thank you.
No, thanks for having me, Jimmy and Winn. I appreciate it.
It was a pleasure, sir. Thank you.
Thanks.